Hello everyone, and in this video we're going to be taking a look at the 2018 IMO Problem 1. And here's how it goes. Suppose you have points D and E on sides AB and AC of triangle ABC, such that AD equals AE. And then we construct the perpendicular bisectors of DB and EC, and they intersect the circumcircle of ABC at F and G. And we want to prove that DE is parallel to FG. And M and N are the midpoints of DB and CE. And they're just used to define the perpendicular bisector, so go ahead and remove them. So this is what we want to prove. So how can we get started on this problem? Well, we have a lot of perpendicular bisectors, so it seems natural to turn them into lengths. So we have FD equals FB, AD equals AE, and EG is equal to GC. Well, seeing FD equals FB and AD equals AE, it seems like we could have two circles intersecting at D. So let's go ahead and construct those circles. So there's obviously circles centered at F passing through B and D as FD equals FB, and similar thing for A. So let's go ahead and draw the circles and see what happens. So there, and then let me go ahead and draw this circle here. So it seems like they actually intersect on the circle here. Suppose this point is X. So what happens if they were to intersect on the circumcircle? Well, we'd have that if we want to prove that they're on the circumcircle, then we want to prove that some quadrilateral is cyclic. So which angles can we use to prove the cyclic quadrilateral? Well, we have that angle AXF is equal to angle ADF because A and F are the centers, and X and D are symmetric across AF by symmetry. So we immediately have right off the bat that AXF is equal to angle ADF. And we want to prove that it's equal to like 180 degrees minus like ABF, ACF, AGF, or something like that. It seems like ABF is the most natural here because we're keeping things on the segment AB. So let's go ahead and do that. We want to prove that it's equal to 180 degrees minus angle ABF. So we want to somehow get ADF is equal to 180 degrees minus something. And we already have that ADF is equal to 180 degrees minus FDB. So that's equal to 180 degrees minus angle FDB. So we want to somehow prove that angle FDB here is equal to angle FBA. And FBA is actually equal to, because of the collinear points, angle FBD. So we want to prove that FDB is equal to angle FBD. But this should be obvious to you because FD equals FB and we have angles. So these circles actually intersect on the circumcircle. So now that we know that, we can clear all this stuff. And keep in mind that we want to prove that DE is parallel to FG. And similarly, the circle with center G passing through E is also intersecting on the circumcircle. So let me go ahead and draw that. All right, now what? And this point here is Y, I suppose. We want to somehow get rid of like D and E from the problem because they seem kind of nasty here. So let's go ahead and do that. we have that F is actually the midpoint of arc XB because F is the center of the circle. That's where that fact comes in. So, and also we have that G is midpoint of arc YC. So, and AX is equal to AY because of this circle here. And we want to prove that DE is parallel to FG. So if we can prove that DE is parallel to something else, and then prove that other thing is parallel to FG, that would work. Unfortunately, we don't really know anything parallel to DE that seems really nice. So let's try doing something like on the lines of perpendicularity. If we can prove that DE and FG are perpendicular to the same line, then we're set. Well, what lines could DE be perpendicular to? The nicest point that we think of is the point A, so we draw the perpendicular there. And then we suppose it intersects at a point Z. We want to prove that AZ is perpendicular to FG. But really, this point Z can be thought of in another way. Because ADE is isosceles, AD equals AE, we have that the perpendicular from A to DE is actually the angle bisector. So point Z is just the midpoint of arc BC. So all of these circles can go away, as well as the points D and E. So let me go ahead and clear out the diagram, because we can now rephrase the problem. So suppose we have a triangle ABC, and then the midpoint of the arc Z. And then we have points X and Y on the circle, such that AX is equal to AY. And then let F and G be the midpoints of the arcs. And then we want to prove that FG is perpendicular to AZ. So prove FG is perpendicular to AZ. So how can we do this? How can we prove that two chords are perpendicular? At this point, you might recall a fact from high school algebra that this angle here is actually the average of the arc measures, AF and GZ. So if we want to prove that this angle here is 90 degrees, which is the average of these arcs, then we want to prove that arc AF plus arc GZ is equal to 180 degrees somehow. At this point, we can just do like a bunch of arc stuff. Since AX equals AY, and that's the dependent stuff, we can go ahead and let that be N and N. And also go ahead and let angle ABC equal beta, angle ACB equal gamma, and then angle BAC is equal to alpha. Hold on. Alpha. So let's go ahead and list the arc measures that we know. By the inscribed angle theorem, we know that arc AC is equal to 2 beta, arc AB is equal to 2 gamma, and arc BC is equal to 2 alpha. And since we want to focus on point Z somehow, we can say that ZC, we want to look at ZC because ZC lies on CG. So that means that arc ZC is equal to alpha. So that's alpha, alpha, and then this is 2 beta and 2 gamma. Well, because arc AY is equal to N, we have that arc YC is equal to 2 beta minus N, and arc XB is equal to 2 gamma minus N. And since F and G are the midpoints of these arcs here, we can find out what XF, FB, YG, and GC are. So let me go ahead and zoom out here. So arc XB is equal to XF, sorry. is equal to just xb over 2, which is gamma minus n over 2. And similarly, arc FB is also equal to gamma minus n over 2. And then arc YG is equal to arc GC is equal to beta minus n over 2. So let's go ahead and focus on AF first. We have that AF is equal to AX plus XF. So N here plus XF, which is gamma minus n over 2, which ends up being gamma minus n over 2 plus n, which is gamma plus n over 2. So now that we have that, so this is equal to AF, now we want to find GZ. Well, we already have an alpha here, so we want to go ahead and get GC. Well, we already have GC, which is beta minus n over 2. So it's alpha plus beta minus n over 2. So CG is equal to alpha plus beta minus n over 2. You might see how to finish this right away. So, but let me finish for you. So we have that arc AF plus arc CG is equal to alpha plus beta plus gamma. And then the n over 2's cancel out. And we want to prove that this is equal to 180 degrees. At this point, something should be ringing in your mind that this problem is actually trivial now, because it's just the sum of the angles of the triangle. So we're done, and this actually ends up being an equality. So now that we've proven this, because of the averaging arcs lemma thing, we have that this angle here in the middle is 90 degrees. So that means that we're done. And as a little side note, some contestants used to prove the problem that f, d, and y are collinear. See if you can prove this on your own here. Let me know in the comments a proof of this thing, and I'll go ahead and check them out. So thank you so much for watching this video. I hope you enjoyed.